This is the Lambda Gator program I've been working on for the past few days, and I'm going to give kind of a quick breakdown of the meaning of the visualization here. But first off, this is based on this alligator eggs game created by Brett Victor, and the idea here is to make kind of an instructional tool. And in the original, you would print these out on colored paper, and then you could manipulate them by hand. And there's kind of a structural correspondence with the lambda calculus, but you could teach its kind of dynamics without having to introduce these really like abstract concepts. So instead it uses concepts like family and eating, death, and birth. So I'll show what the parts mean in my version here. And my version, it's pretty much one-to-one with the game. There's just one difference, which is this concept of old alligators, which just kind of took up too much space. So I have something that's similar, but I think there's a little bit of difference in how he uses it. But I have this bar to represent function applications. Okay, so the major parts are that alligators, so an alligator and everything beneath it corresponds to a lambda term. So let's pick a simple one here. This is actually the, it maps to this section. So the alligator itself is the binder segment of a lambda term, and then what is beneath it here is the body of the lambda term. Or in this case, I mean, you can have a large body, it's a recursive structure, so this can, could go on and get quite large depending on how many nesting levels you have. The colors and numbers both just serve to label variables, and they actually carry the same exact information. I just use the number in case there's any issue distinguishing between colors. And ideally, of course, I would be using the original variable labels, but these just aren't returned by the parser that I'm using. It operates on De Bruijn indices, so it just has no use for the labels and discards them. If you see any negative numbers being used, these are free variables, so there's not going to be any alligator or lambda binder corresponding to them. So the main thing that this does is apply beta reductions step by step, and you can kind of go backwards and forwards. And it's always going to pick this top left most lambda and apply whatever is to the right to it, substituting in this argument for its variables down here. And the animations that I have ended up with are unfortunately not super clear, because, as I mentioned, this has just been a project of a few days for me, but I do think so the original intention was to do animations that correspond much more to something like this, so you could get a better, like, immediate sense of the concepts from the game, like consuming, birth, and death. But I won't go into the details, but basically the way I'm rendering the layout here, it's kind of in conflict with doing those kinds of animations where you have these like specific positional things. Like I would want to move this whole block on the right into the alligator's mouth, and then yeah, let's take a look at just this single step here. So the 2 is going to consume everything on the right, and it's going to get substituted into these variables here, which is going to have the effect of duplicating everything. So ideally, everything on the right would shrink down, go into the alligator's mouth. The alligator dies at that point, and then the substitution takes place. And ideally, that would happen visually by starting with, scale 0, and then expanding these duplicated elements out. So what we actually have, shrink, alligator dies, and we can see that what was on the right-hand side has been duplicated, but it's difficult to make that correspondence between the duplication and the eggs that were down here. So if the animations were improved, I think it could be like far more intuitive to just watch the patterns and kind of understand visually the dynamics of lambda calculus or beta reduction at least. And that's pretty much it. There's some more information here. Definitely check this out. This is important to note. Yeah, it's a major limitation and it's super annoying, but I just have not had time to do something better. I guess one other thing I'll show real quick is just kind of demonstrate partly the syntax, but also how this like load program thing works. I would have it just update the visual, like reparse every time a character changes, but because of this infinite loop issue, that's not really possible. So when your program is ready, hit load program, and you'll see everything change. And yeah, you can use the L character instead of the lambda symbol. And whenever you have function applications, though, this is a little tricky because there's a lot of variation in lambda calculus notation, and most of them are more abbreviated than this. So you might see something like that. But it is, the parser is very particular, so all applications do have to have parentheses, and they need spaces between left-hand side and right-hand side. And this here is our omega combinator, which just runs forever. And so we can see that's working. And that's it.